4 on worksheet 2.3 gave you the following information. It said the velocity at time t is equal to 5 times the sine of t. Question A wanted to know what's the displacement between, and then it gave you 2 times. So the times were pi over 6 seconds and pi over 3 seconds. Okay? So, real quick again, just to reiterate, I did send out a reminder about the corrections on the answers here. I made a little mistake when I wrote up my answer key, so hopefully everybody got that. All right, so, Sarah, I think you asked about this one, yeah?
Yeah.
Is that right? Okay. So, did you have some inclination of where you were supposed to start with it?
I know it has something to do.
Okay, so what's the significance of that negative cosine?
What do you mean that's?
Like where did the negative cosine come from? Like,
It was on the note thing.
okay.
Yeah.
Where on the note thing? There's a word I'm trying to get you to use here. Right.
I don't know. Like,
Okay, sorry.
Sorry.
So, no, you're okay, I think I'm not asking the question that I want to ask, literally. So, look, you guys, we're given an expression for velocity as a function of time, right? And the problem is asking us to find the change in position. Emphasis on change in position. So, what path should we be thinking about as we try to solve this? Sure, we got that. Integral. Take an integral, right? Okay, and so what we want to do then is we want to find our displacement. We want to find the integral of our velocity as a function of time, with respect to time, between these 2 time bounds, right? Because we're looking for a change, that means that I want to bound my integral so it becomes a definite integral, right? So I want to take my integral between pi over 6 and pi over 3, right? So is everybody okay up to there? All right, now, so then the question becomes, great, but what the bleep is the integral of 5 times the sine of t? And so this is what I was trying to have you get at, is that, so what's the integral of sine, you guys? Negative cosine, right? So that was all I was trying to get you to say, is negative cosine is the integral of sine.
Sorry.
Nope, that's okay. I think I was asking a really open-ended question and you needed more direction. You're good. So, I guess here's this then. Do you guys understand? So that day I gave you guys notes on derivatives. I gave you a little cheat sheet that said, all right, here's a function, here's how you find the derivative. Here's a function, here's how you find the derivative. Do you guys understand that that sheet also tells you how to take integrals? That you're just going backwards, right? Okay, so on that sheet, there's a little thing that says, okay, the derivative, I don't remember the exact order of these, but there's a thing that says the derivative of sine of x is it cosine or negative? Cosine. I always need to stop and picture the graphs. All right, and then the derivative with respect to x of cosine of x is negative sine of x, right? Yes. So going this way gives you the derivatives. That means going this way gives you the integrals. So in other words, the integral of negative sine is positive cosine. Do you see what I mean? So if the integral of negative sine is positive cosine, then what's the integral of positive sine? Negative cosine. Yeah.
We have that.
So I'm glad you asked that. You do not get that, but you do get the AP Physics C Equations Approved List, which has on the back a list of common integrals. So I'll let you guys look at that, but it's, so sine and cosine are on there, natural log is on there, all the ones I gave you are on there. Good? Cool? All right, so I guess I would say maybe as you're studying, go back and look at that and make sure that all of the notation makes sense to you. And if not, then, grab me and go, ooh, what's going on here? Cool? Okay. Are you good up to there, everybody? Sarah, everybody? Cool. All right. So, progressing from there then, so we just decided that the integral of sine is negative cosine. Multiplying by 5 doesn't change anything, so you get negative 5 times the cosine of t. Good. So that's my integral, and now I need to evaluate it at pi over 6, and pi over 3. So this becomes negative 5 times the cosine of pi over 3 minus negative 5 times the cosine of pi over 6. And it gives you whatever I texted out that the answer was. What is it? 1.83, that rings a bell. And what should my units be? Meters, because it's a displacement. So are you good?
Yep.
Are you lying so I'll leave you alone?
No.
Okay. I appreciate that you stopped and thought about it. All right, are we good, you guys?
Yeah.
All right. Yeah.
So if I were to plug this, really dumb question,
Not at all.
plug this in a calculator. Sometimes I get like weird answers, and I don't know why, but like,
Make sure your calculator's in radians. That's
or-
probably the issue, would be my guess. And I will be honest with you, I did not realize until last week that you could literally type this into your calculator and get an answer. I want you guys to show me the work of taking the integral, and I will be expecting that. All right? And I will, in the meantime, I will find out if it is acceptable to use a calculator to do that. I'll be honest with you, though, I don't think that I've seen any AP tests where your integral comes up with a numeric answer. It's all letters. I.e., you got to know how to take the integrals. All right, are we good?
Yep.
Any questions? Once, twice? Okay, cool. So that was, what was that, 4A? So 4B, it said if the object had a position of 6 meters at t equals pi seconds, then what's its position at t equals 2 pi over 3 seconds? All right, so there are two ways that you can do this problem. Option 1 is to do kind of the same thing, where you integrate from pi to 2, or I guess 2 pi over 3 to pi, and find the change, and then work backwards. I'm going to do it slightly differently, though. Let me do this. So here's what we know. So this is 4b. So we know that our velocity at time t is 5 sine of t, right? All right, this question isn't specific, part B isn't asking you for change, it's asking you for an instantaneous position. Follow? You guys understand why that's different? Okay, we're not looking for change. So let's do this. Let's see if we can come up with an expression not for change in position, but an actual expression for position as a function of time. Okay, and so the difference is now instead of taking a definite integral, I'm going to take an indefinite integral. And what do you have to do when you do the stupid indefinite integrals? So you got the stupid plus c, right? That's what makes it indefinite, right? Like, ooh, plus c, right? So it's the integral of v of t with respect to t. That's the integral of 5 sine t with respect to t. That's negative 5 cosine of t plus c. So I did that really quick. The integral is the exact same thing we did before, like, going from 5 sine to negative 5 cosine. But it's got that stupid plus c, right? Because think about it, if I take the derivative of this mess, what's the derivative of a constant, you guys? 0, right? So that's where that plus c comes from. And we just don't know what that constant is. So, is everybody okay up to there? You guys gotta ask questions if you got it. Okay, so now the problem gave us one other bit of information. It told us that at a time of pi, let's see, if the object had a position of 6 meters at t equals pi seconds, then blah, 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 blah. So the idea is, I know that my position after 6 seconds, I know that my position after pi seconds is 6 meters, right? So what am I going to do? Plug pi in for my time, plug pi in for my time and solve for c, right? So here's what we've got. We've got 6 meters equals negative 5 times the cosine of pi plus c. What's cosine of pi? negative 1. So this is 5 plus c. So that means that c is 1, right? Ha ha. So now I know how to find the position at time t. It's negative 5 cosine t plus 1. Because that's what c is. So now I can plug in any value for t and figure out what the position is. So now we just plug in 2/3 and you're done. Or 2/3 time. Too fast? Are we good?
I'm good.
Sarah, you good?
Yeah, I'm fine.
Everybody happy? Anybody unhappy? Teddy, you alright? What you drink? Coffee, is it delicious? What you got? Is it just black?
Just stays.
Just black? Green. All right, numero 5. All right, so a bunch of you guys asked about 5. Was 5 difficult because of the physics or because of the calculus? Or both? Adam, you asked about this one?
Yeah. I asked about 6, but this.
Oh, okay. But 5 was on your list too? Okay, all right, so let's do it. So here we go. Acceleration as a function of time is 3 over t. Question A wants to know the velocity at 5 seconds. The other thing that we do know is it tells us that the velocity after 3 seconds was 4 meters a second. All right, so we're given information about our acceleration, and we're asked a question about our velocity. So, Adam, I know you asked about another one, but I'm picking on you because, hi. What are you thinking? Get me started.
To rewrite a at t seconds to make it easier,
3t to the negative 1?
Yeah.
Okay. I agree that that's the same thing. You know what I wish I had done at the beginning of the hour, and I'm going to do it right now real quick, so give me 1 second. Recent items, chapter 2 notes. Okay, so why are you thinking that we want to do that?
Because it just puts everything like together.
Okay, so we can kind of use the exponent rule?
Yeah.
Is that sort of where you're headed? Okay, so let's take a quick look at the little cheat sheet that I gave you guys with all the derivatives and stuff on it. It's in here somewhere. Haha. Okay, so are you thinking we want to write it that way to get it into this form? So that makes good sense to me, okay? But so here's the deal, you guys. What the power rule tells us is you bring the power, when you're taking a derivative, you bring the power down in front and then decrease your exponent by 1, right? Okay, so check it out. Look, let's do this. So suppose I give you a function, x cubed. What would the derivative of that be? 3x squared. Okay, so it's possible to take a derivative and get a squared as an answer. Derivative of x squared would give me 2x. Derivative of x would give me 1 times x to the 0, which is 1. Right? Follow? This is going somewhere, so bear with me for a minute. X to the 0, well, that's the same as 1. What's the derivative of a constant? 0. All right, x to the negative 1, which is the same as 1 over x, which is, I think, what you were thinking, right? So if you take the derivative of this, you get negative 1 times x to the negative 2. Cool? Everybody good? All right, so on this side, I can have an x to any exponent, right? I can have x cubed, x squared, x to the first, x to the 0, x to the negative 1. But after I take a derivative, can I get any value, any exponent of x? There's one missing on this list. Like you can see that if I go up, I can get x cubed, I can get x to the 4th, right? I could get x to the negative 2, x to the negative 3, but there's an important one missing. Yeah, the x to the negative 1 doesn't show up over here, does it? There's no monomial. Does everybody know what I mean when I say monomial? Like x to a power, basically, right? There's no monomial that I can take the derivative of and get x to the negative 1. Right? So, that is why it's the special one. Okay? So, the integral of 1 over x, or in this case, the integral of 1 over t, you can't use the power rule. Because there's no way you can take a derivative of a power and end up with t to the negative 1. Okay? So the integral of 1 over t is the natural log of t. Okay? That will become more important as the year goes on. I put it here to alert you to it so that you guys could have that oh moment that you almost had. Okay? Does that make some sense? Okay. I overheard somebody the other day talking about a chem equation that helped them remember this one.
Oh, reaction rate laws. Oh, reaction.
Is that worth explaining? How many of you guys took AP Chem?
I wouldn't.
No, not worth sharing? No? Didn't help you? Okay. All right. Okay. So anyway, so just remember that 1 over t, that's the weird one. If you want to integrate t to the negative 1, or 1 over t, it's natural log. Okay? It will come up on the AP test. Every other year, you know what I mean? Like there's a high probability that it could be happening. All right? Good? So, what the bleep does that have to do with this? Well, we've got acceleration, so to find velocity, we want to take an integral. And the integral of 1 over t, or 3 over t, is going to have something to do with the natural log. Follow? So, v as a function of t is the integral of a of t with respect to t. I'm trying really hard to write notation properly so that you guys get used to seeing it. And I understand you might not be doing that yet, but by the end of the year, I'd like you guys to be there. Okay? All right, so this is the integral of 3 over t with respect to t. Good? I don't know that you have to do this step, but technically this is the same as 3 times the integral of 1 over t dt, and then it makes that clear that that's going to just be 3 times the natural log, right? Okay. So you get 3 times the natural log of t. What? Plus c, right? Because I'm taking an indefinite integral. Follow? All right. Questions up to there? Yes, that's.
We add c. Why do we add c here?
So remember,
Is it because it's instantaneous? Is that the?
Yes. Yeah, that works. Everybody good? Okay. Okay, so now, let's see, where do we want to go from here? We want to extend our page. Okay, so we know this, right? We know that the velocity after 3 seconds is 4, right? So that's sort of your name for this thing, just drawing a blank. Whatever, we know that point, right? We have a known point, and we can use that known point to find c, right? It's kind of like in math where you plug the point in to find your y-intercept. Same idea, right? Okay. So here we go. So our velocity after 3 seconds ought to be 4. So I'm going to plug in 4 here for my velocity. That's equal to 3 times the natural log of 3 plus c. This gives you some mass solved for c. All right, so c is going to be, what, 4 minus 3 natural log of 3? Okay, we'll grab my calculatrix and figure out what that is. 4 minus 3 times natural log of 3. Close the parentheses. So you get 0.704. Incidentally, what are the units on that c?
Meters per second.
I heard meters per second. So this was the function. This is a function for velocity, right? So I've got velocity equals some number plus some number. Can you add something plus meters and end up with meters per second? No. Apples and apples, right? You can't add apples and oranges. So these both have to be in units of meters per second. Follow? Do you know what I mean with the apples and apples thing, Peter? Is that what you're doing? You good?
No, it's a long story.
Okay. But you're on board. You're good?
Yeah, totally.
Okay, cool. Adam?
I'm confused about one thing. So we know that ln to t, or ln t is equal to 1 over t. So ln of 3 would technically equal 1 over 3 times 3 would be 1.
Whoa, say that again.
So, can I write it?
So you've got 3 ln of t, and when you take the derivative,
Well, we know that ln t is 1 over t. We know that t is 3. In that certain scenario.
No.
oh, I gotcha. So what you're doing, that would give you the acceleration at that moment. So remember, we've got two expressions here.
Oh, I got you. Okay.
So you're right. So your acceleration at 3 seconds is 1.
Yeah.
Totally. But what we are looking at is not the acceleration at 3 seconds. We're looking at the velocity at 3 seconds. You good?
Yeah.
You kind of like worked in a circle, sort of. You took the integral and then went back and took the derivative. Yeah. All right. Is everybody good? Problems, issues, concerns? Okay. So now that I know this, I can find my velocity after 5 seconds, right? Just plug 5 into this, right? Everybody good? Okay. Do I need to talk about anything else from that problem? Let's see. B says find the change in velocity. Well, I guess at this point, I would just find the velocity after 12 seconds, find the velocity after 7 seconds, and then subtract, right? Follow? All right, and then C says, what's the initial velocity? And then I put a whole bunch of exclamation points there. So let's see, here's what we know. We figured out that our velocity as a function of time is this equation. 3 times the natural log of t plus 0.704. So what is question C really asking us? I need somebody to reword that. Because what's the initial velocity? What am I asking you? Sure, we got there. Good. When time is 0, what's the velocity, right? So there's a couple issues here. First of all, the acceleration at that point is undefined, right? Why? You can't divide by 0, right? Okay. So that seems like it might be problematic. Secondly, and I know you guys are probably not super familiar with logs, because they're sort of like the evil, like nobody likes them, right? What's the natural log of 0? Also undefined. All right, check it out. Let's graph this thing real fast. If my computer will cooperate with me. Incidentally, if you've not used Desmos, it's super cool. And there's an app for it too. It's a really, really good graphing app that I like better than stupid TIs. All right, so what did we have? We had 3 times the natural log of t. I got to use x here, and then it's plus 0.704, right? Okay, so here's my function. If I zoom out, here's t equals 0. What's the name for t equals 0 in this graph? Asymptote. It's a vertical asymptote, right? What's the velocity doing? It's going to negative infinity, right? And your slope is positive infinity, right? It's almost vertical, right? Follow? Yes. All right. Questions? Okay, cool. All right, so I think the last one we got to do then is number 6. Yes? Yep. All right, so number 6 was tough, I think probably just because the integrals are kind of a drag. Here's what I want to say, you guys. I think in the notes, I'm not sure that I did a great job showing you this little trick of plus C and then plugging in a point to find C. We've now done 2 of these. These are important, like that will come up, where you use a point to find the value of C. So you need to be familiar with that little trick. Good? When does the bell ring?
You've got like 15
15 minutes. Okay, good. Thank you. Okay, so number 6. All right, I have stopped sweating enough. I can put my shirt back on. That won't sound weird on YouTube. Ooh, what you got? Okay, here we go. Number 6. Okay. So honestly, this is basically more of the same. Like I said, I think what makes this hard is just taking the integral, right? So question A says find the velocity after 0.5 seconds. So here's what we know. We know that the velocity after 1 second is not that. The velocity after 1 second is this. And the question wants to know what's the velocity after this. Right? That's our question. That is our task, which is set out before us. So hopefully you guys are all thinking, oh, I know the acceleration. I'm trying to find velocity, so I should take an integral. Definite or indefinite?
Indefinite.
Indefinite, because we don't know, or because we're looking for an instantaneous value. So v of t is our integral of a of t with respect to time. So that's the integral of 6 minus t to the negative 2 plus t to the negative 3 with respect to time. I will pause for a minute so you can get caught up with your writing.
Mr. Becker, would you prefer that we use decimals or fractions?
I honestly don't really care. The math part of me says fractions. Sometimes I think it'll be easier. Like if you've got 1/3, it's going to be easier to write 1/3 than 0.3 repeating. I don't know. Use your judgment. It doesn't matter. Okay, everybody good up to here? All right. So our question is this, and this one's tricky because the exponents are negative. Our question is this: what do we take the derivative of to get 6? 6t. And how do I know it's t? Because it's with respect to t. Okay, because of that dt. That's what that dt tells us. All right. Now, Patrick. I would try to avoid doing that. I don't know the answer. I will make a note to ask. I think you would be. The more I think about it and the way I'm thinking about the way the rubrics are set up, I think you would be marked off. Yes, I would use t. Or whatever your variable of integration is. Because they want to be able to follow your work. And if you switch to x, they're going to think you're integrating with respect to position instead of time, which is not correct. Maggie, I'm trying to teach here.
I almost died.
I'm glad you're okay. All right. So now here's the rub. What do we take the derivative of to get t to the negative 2?
Plus 1t to the negative.
So remember, you guys, when you take a derivative, you subtract 1 from your power. So what do I subtract 1 from to get negative 2? Negative 1, right? Not negative 3, negative 1. So what has to go here? Plus, right? Because that way when I bring the negative 1 down, I'll get a negative. You guys cool side conversation? Thank you. All right, is everybody good up to here? All right. Similarly, what exponent do I have to have here to end up with negative 3? Negative 2. So what has to go in front of it so that I get 1? I think negative 1/2, right? Because then when I multiply negative 1/2 by negative 2, I get positive 1. Follow?
Yes.
All right, and then what else do I need to do that I haven't done yet?
Plus c.
Plus c, right? So let me pause there for a minute. I got some feedback from some students who took BC last year that was a tough integral. This one in number 6. So I would not do this to you on a test yet. But eventually you need to get to this point. So let's ask questions now while we're here.
So, as long as everything is in terms of t, could you call c v0?
No. Oh, I'm so glad you just asked this. This is what I kept hesitating. I don't know if you guys remember. Last week I kept hesitating with saying that the c has meaning. And very often the c is your v0. Unless you've got a weird function like natural log. Right? Because remember, what was our v0 in this problem? Do you remember? It was undefined, right? But our c was not. Okay? So as long as you're talking about a polynomial, that's true, that your c is equal to your v0. But if you're doing something else, like a trig function or a natural log, it may or may not be, depending on the way the function works out. Really good question. Really, really good question. Okay, so is everybody good up to here? All right, so now I've got a function. I know that the velocity after 1 second is 7.5, right? So I ought to be able to figure this out, right? So 7.5 equals, and just put 1 in for t, right? So you get 6 plus 1 minus a half plus c, and solve for c, right? So I think this is going to give us, what, 7.5 equals 6.5 plus c. So c again ends up being 1 here. And from there, you can do the rest of the problem, right? Yeah, right. The moral of the story is c is always 1. Okay. Questions, you guys? Okay. So, here's why I'm hesitating. I would like you guys to spend a little more time with the lab before we do the test. But I also want to go over worksheet 1.4. Or, sorry, I'm looking at the wrong class. 2.4.
Let's just do the test back today.
14 days.
Well, so
How BC has a test tomorrow?
We're gonna
It's Wednesday?
I thought it was Tuesday. I thought it was Tuesday.
okay, so regardless of when your BC test is, so did anybody finish? Did any groups completely finish the lab the other day? Or you did because you came in after school that one day and killed it. So high five. Cool. Anybody other than Teddy finish it already? Okay. So you just got to crunch the numbers. Okay. All right. So let's do this. I think there's value in still having 2.4 due tomorrow. Let's make Wednesday though a day to work on the lab, and maybe I will start the next chunk of notes. Well, it's totally unrelated. It's vectors. Like it'll be super easy. All right. So anyway, so long story short, 2.4 due tomorrow. Wednesday will be at least lab, maybe some notes. Test will do Thursday. Good? Yeah.
So lab needs due the day of the test.
Oh, no, we'll talk about it. No, absolutely not. It'll be due Friday, or I'll probably just make it due Monday, so that way you just have time to do it and do it well. Fair? All right, when do we get out of here? 09? Okay, all right, you have 5 minutes to chill.